Hi, it's me again, Crewbase, and I'm gonna walk through this paper, IALP 3, October 2024. It's the most recent paper as of the time of recording, which I've never done and never seen before. So I will be timing myself while I'm doing it, and there'll be no cuts and no edits after I hit the timer. I'll mark the paper at the end, and then I'll give you the feedback after having done the paper. I really do hope this is going to be useful for you guys. And if so, please hit the subscribe button. Okay, let's crack some eggs. Just going to go ahead and do the first question here. All right, so the first question is about trig. Yeah, so I'm just going to write my first question here. Trig, solve for 0 to less than theta less than 360, that equation. So guys, as soon as I see this equation, we have a tan squared and a sec, right? So the identity with the tan and the sec should come into your mind, right? So the identity says that if we have tan squared x, no, if we have sec squared x minus tan squared x equals 1. So here it seems like if I substitute tan squared in terms of sec squared, it's going to give me a quadratic function with only sec theta, right? So I'm going to be doing 10 squared here, x is equal to 6 squared x minus 1, just rearranging. And substituting into this equation, so we would get rid of 10, so we have 3 in bracket 6 squared x minus 1, right? Plus 7 sec theta, not x theta, yeah, sorry. And then minus 3 equals 0. So just expanding all out, we get 3 sec squared theta minus 3 plus 7 sec theta minus 3 equals 0. I'm not going too fast, guys. And then simplifying every term before we solve quadratic, we would get this. Okay. Yeah, just checking everything, see if I got it right. Just being careful here. Yeah. So now, normally I would just go and factorize by myself. So I'll try that, see if I can do it. Okay, so I'm factorizing it quadratically. So I'm going to try looking from minus 6 here. So what do I have? I have a 3 and a 2 maybe, but one of them should be a minus. I'm guessing the bigger one should be a plus here and the smaller one a minus. And that works, right? We get a 7 in the middle. Okay, so that means we have two set of answers. One being sec theta. So if you look at this one, we can do like 3 sec theta minus 2 equals 0, or sec theta plus 3 equals 0, right? Okay, so for this one here, sec theta isolated to be 2 over 3, just do that. Or this one, sec theta is minus 3. Now, guys, I would recommend before you solve these trig equations, you should actually look at the range here, the range of theta. And it happens to be okay in this case because we don't have any derived expression for theta. It's just theta. So if it's not theta, like something else, say 2 theta plus pi over 2, then we would have had to change the domain to something else. And if I have the opportunity in this paper, I'll show you later, right? So we are using cast diagram here in this case. And don't forget that sec is just 1 over cos. So if we have cos instead, we're going to flip the right side here being 3 over 2. And the other one the same. So cos here being minus 1 over 3 instead. Because if we want to solve using a calculator, we need to do a basic function sine, cos, and tan. Okay. Now, seems like this one doesn't have any solution, guys, because for cos, you cannot exceed 1, and that is already 1.5, so no solution here, all right? But we would be only interested in the cos theta being minus 1 over 3 here, so using cast diagram. We would like to do what's called a basic function first, b dot a, basic function. So I'm just doing that by taking arc cos of a positive value here, okay? We only take the positive value there. And so this one is in degrees, so I need to change on my calculator there degrees. And then I'm doing arc cos 1 divided by 3 there. So I'm getting the basic angle to be 70 point. We're going to do to 1 decimal places. So I'm doing 2 decimal places here to be safe. All right. So 70.353. And using the cast diagram, right? So hang on. The cast diagram. The basic function here is used in conjunction with the selection of the right quadrants. So this one tells me that cos being negative, and we only get cos negative in the second quadrant and the third quadrant. And 70.53 here would be the basic angle that is just adjacent to the x-axis, right? So 70.53 here and 70.53 also here. But the way we measure the angle would have to be from the positive x, anti-clockwise being positive angle and clockwise being a negative angle. But here we only have a positive range. So I'm just going to measure the angle, this one like that. So that angle would first be theta equals, the first angle would be 180 minus that angle, right? Yeah. And the second one would be what? So this one, I'm just going to say, okay, 180 minus 70. I probably don't need a calculator for that. So I'm going to do, this is 109.47. All right. See if I got that right. Yeah, I should. Okay. Or equal 109.5 to 1 decimal place, right? And then the other solution would be going another angle there. So we have another root there. And this would be 180 plus 70.53. So 180 plus 70 is about 250. So 250.5 would be the answer. All right. So that's about it. So we only get two solutions here, 109.5 and 250.5 answers to 1 decimal place. So that would be my first work solution for number 1. Number 2. Okay, so figure 1 shows the sketch of the curve there. Find dy by dx in terms of y. Got to be careful there, guys. So because we are given the question as an x in terms of y. So the easiest way, I think, is to do dx by dy. And then we can flip to find dy by dx. So dx by dy would be differentiating y as if we were differentiating x, but it's just in terms of y, right? So differentiating 2y squared would be 4y here, bringing 2 down, multiplying 2, and y subtracting power by 1. And this is 5y, so it just becomes a 5, and minus 6 goes away. So that means dy by dx would be 1 over that, guys. No big deal here. And that is just it. I don't need to simplify anything else. So that should be fine. So that is A. So B, the point P lies on the curve and is shown in figure 1. So point P is over there and is parallel to the y-axis. This is very important, guys, because most of my students don't quite realize that, okay, they do realize when they have a curve like this and they have a tangent, so they know this is a turning point because that is like flat or horizontal to the x-axis. But when the curve is like this, they got stuck. Well, actually, it's just a kind of turning point, but it's turned the other way around. So instead of dy by dx being 0, you have now dx by dy being 0 at that point, right? So we will equate dx by dy being 0, and then we solve. So we're going to put that to the dx by dy being 0 here. So there you go. Okay. So that means y solving this linear equation would be minus 5 over 4. Yeah, that's the y coordinates of the point P. Okay. So the y coordinates of the point P, we just find it. So this is y coordinate of point P. So the x coordinate of point P would be just using the curve function there. So xp would be equal to using this main equation here. So 2 times y, which is found to be that, and then squared plus 5y minus 6. Yeah. So I'm just gonna maybe put that in a, no, I don't need a calculator. So this is 25 over 16, so 25 over 8, right? Minus 25 over 4 minus 6. So if I make everything in 8, so I have 25 minus, so this is minus 50 because I'm going to make everything over 8 here. And this will be multiplied by 8, so it is 48. So doing all the math there, I get minus 73. Yeah? Yeah, that should be right. So that means coordinates of point P would be x being minus 73 over 8 and y being minus 5 over 3. That makes sense because x seems to be further away from than y being further down, right? So that kind of like, okay. We can double check later if you want, right? But yeah, that question was done, right? Number 3, next page maybe. So figure 2 shows a sketch of the curve with equation y equals fx, and they give you the graph. In P3, guys, if you have the graph, use the graph, right? In any question. Okay, so in question A, we're going to solve the equation first. The equation f absolute x, but we have fx to be this guy, 2x squared minus 10x. So if we put absolute x in there, we're going to get absolute x and then squared minus 10 absolute x, or modulus, sorry. And then we equate this to 48. Now, you need to know this property in order to take it forward. Absolute of modulus x and then squared would be the same as x squared. It doesn't matter what kind of number, negative or positive, you put in the modulus here. When you square it, it becomes a positive anyway. So that means we can reduce this to just 2x squared. But modulus x here, we cannot modify it, so we keep it like that, right? Okay. Well, actually, come to think of it, I see the graph, and I told you myself that I should use the graph. So let's use the graph. So this graph is just fx, yeah? So if we want f modulus x inside, right, inside the brackets like that, it's going to be like you will cancel this part and make the right part and reflect to the left. So that will be something like this. So we will cancel this part. And these are mirror images, left and right. So, and then we want to solve it equaling 48. So you just draw a line of y equal 48. The solutions to that equation would be the intersections of the two graphs, right? So that is already that. Yeah, okay, let me just write down. This is f absolute x. Okay, so the blue points here will be our solution. So there are two solutions here. Just got to be careful. All right, so how do we solve this? Well, we can go ahead and take this part here, where this curve is going to be the original curve, 2x squared minus 10x. So I probably don't need the working for this because I'll share you my model answer later on. So got to be quite neat there. I can't move this up, sorry. Okay, yeah, that's my curve. So I'm going to solve for this part, 2x squared minus 10x equal 48, because I want to know where it cuts the line here, yeah? So simplifying by dividing through by 2, I get x squared minus 5x, and 48 divided by 2, I get 24. Move it to the left, I get minus 24. Okay, this will be, can I use 4, 6? No. 3, 8. Yeah, so I can do x minus 8 and x plus 3 to factorize that. So that means I get x equals minus 3 or 8. Well, that seems to me like this is going to be, what, 8, right, guys? Because minus 3 is on the negative side. So I get x equals 8 on this point. Okay. So what do you think? The other point is a reflection. So that must be a minus 8, right? So therefore, we can answer x equals minus 8 and 8. Yeah, that's it. So use the graph, guys, I think would be a better choice. Okay, B, find the set of values of x for which it satisfies that inequality. So instead, now this time we have a modulus outside everything. And you should know that when we have a graph, a quadratic curve like this, and that's fx again, we can have to flip this part up. Yeah. Whatever is below, whatever part is below the x-axis will be flipped up, right? So I'm going to delete that out. Okay. And then that is the modulus of fx outside everything. So again, the right part here, we just plot the line, right? So this is a kind of a straight line passing origin. So it may look like that. I don't know. We don't know for sure yet because, yeah, let's just do that. Hang on, let me change that to a nice line. Okay, there you go. So, I mean, I don't know. It might do that or it might do that. So depending on, the gradient of the curve around that point. So let's do something like that first. All right. So this is the straight line, y equals 5 over 2x. All right. But for sure, it's gonna intersect with the curve in quadrant 1. It cannot intersect anywhere here. So our answer to this should be positive x values. But how do we solve it? Okay, if you look at the curve here, if you reflect, right, because this is a reflection of the main curve, and again, this is fx, and fx, if we bring it back again, is this guy. Now, if you reflect this part, right, it's a reflection, it is like you're gonna, instead of having a normal parabola here, where the maximum point is down here, you're gonna have it up here, right? So you're gonna have, okay, let me think about that. Okay. So it's like we can put this whole thing to a negative. Yeah. So I'm gonna put to a negative to make it a like inverted parabola and equate that to the line we want here, which is 5 over 2x, right? Yeah, so we solve this equation. Yeah. So I'm gonna get minus 2x squared plus 10x minus 5 over 2x equals 0. Simplifying by multiplying all out by minus 2, I get 4x squared. Then minus 20x. Minus 2 times that, I get a plus 10x equals 0. Yeah? Okay, just checking. And then I would get 4x squared minus 10x equals 0. So I have here 2x, x minus 5 equals 0. Just factorizing that. Oh no, it's 2x inside. Okay. All right. So x here is going to be 0 or 5 over 2. All right. So see, it cuts there at 0 as well. Okay. 0 is one of the answers. All right. But yeah, okay. So 0 to 5 over 2, right? So let's make the line a little bit like more obvious. So maybe let's make it like that. Yeah. Okay, and we can see that 5 over 2 may be, wait, actually, let's find where the maximum is, right? Because we can do that. So we know that if we factorize this guy, it's going to be, yeah, it's going to be 2x and then x minus 5, right? That's the factorization of that part. So this is 0 and 5. So 5 is here, 0 is there. This should be 5 over 2. So actually, the line, just out of interest, cut at the maximum. Yeah, it should look like that. Yeah. All right. But okay, we actually want where the modulus function is above the line because it's a greater than sign. And that only occurs at this part right here. Modulus above the line. Wait, I also have that part, right? Yeah, it's also above. So that part, this part doesn't count because it's below. And then we might have another point again later on. So this one is tricky, guys. You got to be careful. Yeah, because look, the curve will cut the line again later on. Yeah. So here it will cut again later on. So we have, okay. So we have from this point to the left, right? To the far left, because all of them will be above. Yeah. So that point will be x less than, right? Less than or equal. Well, yeah, less than equal because we have an equal sign here. So less than equal, whatever this is, 5/2. Okay, that's the first part. And or, yeah, or we got to find this intersection first, guys. Okay, so to find that intersection, we need to equate the normal, the unmodulus, if you like, function here, equating with 5/2 to see where they cut, right? So I'm going to solve for that and solving it. So again, oh, 5/2x, I almost got it wrong there. Okay, so again, multiplying out by 2, I would get 4x squared minus 20x, and multiply that by 2, I get 5, so minus 5x here. Okay. Okay. Wait, hang on. This is weird. I shouldn't have this, right? Hang on. Yeah, how can I get 10 here? This is not 10. This is just 5. Oh no. I spot that. This should be a minus 15. That's not good. Okay, so I'm gonna do this again. So this is x and then 4x minus 15. So that should be x equals 0 or 15/4. I need to double check this. I can't rely on my mental math today, maybe. So, okay, let me just double check that again. So if I multiply by minus 2, I get 4 there, minus 20x, and then 5 here. Yeah, okay. Right, this should be fine now. So actually, it's not at the maximum. It is after the maximum. It is after the maximum. So there's no point knowing the maximum there. But anyway, so that's not the maximum, guys. This is, yeah, 15/4 instead. All right. So again, solving, okay, let me change that to, so this is now 15/4, right? Okay. So multiplying by 2, yeah, I got that. So yeah, 4x squared minus 25x equals 0. So again, factorizing x out, I get 4x and minus 25 equals 0. So this is now 0 and 25/4. But I mean, it should be 25/4 now. This is about 6 and a bit. So yeah, it makes sense because we have here 5 still for this curve. So this point right here is a bit to the right to 5. So that makes sense. We want to the right part of that point because that is where the curve will be above the line again. So that's x greater than or equal 25/4. So this is my answer. Okay. All right. Okay, that's done for B. I think we probably need to come back and check for that later after we finish everything. Okay, number 4. The number of bacteria on the surface is being monitored. The number of bacteria in the surface T hours after monitoring began is modeled by the equation. Blah, blah, blah. Use the equation of model answer parts A to C. All right. Find the initial number of bacteria on the surface. Well, initial we put T equals 0, guys, because that's what it means. Okay. So T equals 0, we have log 10n, log base 10 of n equals. So all that term will go to 0. That's plus 2. So this side is 2, basically. If we want to make n the subject to find the initial number here, that would be moving 10 as the base of the index on the right side, bringing 2 up. So that is just 100. Yeah. So that part is fine, A. And B, show that the equation of the model can be written in that form. So basically, we can just, again, I'm just going to repeat the question there, the equation, I mean. So again, in my previous videos, I showed that when you have this, you can just pull the base 10 as the base of the index as a power to the power of the whole side. Okay, so it's like that. That's the vivid imagination if you might want to follow that trick. So n here would be equal to 10 raised to the power of the whole thing on the right side. Pretty easy. But then using the laws of indices, when we have a to the m plus n, we can split it into a to the m times a to the n. Yeah, so that would be 10 to the power of 0.35t times 10 to the 2. And if you look at the form here, we already follow it because a would be 10 to the 2, which is 100. And then b would be 10 to the, well, because the power is just t, we need to sort of like bring 0.35. So it's going to be like this, guys. And then raise the power of t. You can also do that using this property here. So we have a to the m times n. We can do a to the m then to the n, or you can do it the other way around. Doesn't matter. These are equivalent. And then we need to give a and b constants to be found. The value of b to be 2 decimal places. So I'm just going to use my calculator, 10 to the 0.35, right? There you go. And that gives me 2.2 decimal places. So 2.24 to the t. Yeah, that's it. C, hence find the rate of growth of bacteria on the surface exactly 5 hours after monitoring began. So basically, rate of growth, you can differentiate, right? So that's dn by dt. Yeah. Okay. So we just differentiate n respect to t. Okay. So now differentiate an exponential. So I'm just going to write here d by dx of a to the power of x. A can be anything, doesn't have to be an Euler number. So you're gonna get a similar result to an Euler, but you're gonna have to multiply back by ln a. So if this is 5 to the x, you're gonna have 5 to the x ln 5. All right. So we're gonna ignore the 100 there because it's just a constant. We don't need to do anything. So differentiating this, we get 2.24 to the t, but then I multiply in extra the ln 2.24, right? Or if I would prefer a more exact version, I can do 10 to the 0.35 there. Yeah. And then I would like 5 hours exactly after monitoring began. Okay, so t equals 5 there. So dn by dt at t equals 5 would be substituting everything in, guys. Okay. Okay, so I'm just going to put everything in my calculator here. So 100 times 2. Yeah, but 2.24. Wait, okay. So 2.24 is also the 10 to the 0 point thingy there. Okay, so I'm just going to do 10 to the 0.35 also to the 5 because I want to keep it exact. That's just my thing. Okay. All right. So, oops, 100 times 10 to the, so 0 point is just 0.35 times 5 there because we can bring 5 down to multiply with that guy. And then times ln. Yeah, this time I have a ln. Where's a ln here? Ln. And then 10 to the 0.35 there. Okay. Yeah, I think I got everything there. Yeah, just checking. All right. So I have 4,500. Okay, find the rate of growth. Yeah. I'm just going to keep it as something like that. Yeah. Probably. Let's have a look at this later when we check them. Okay. Number 5. All right. Number 5. Show that sine 3x can be written as that form. Okay. I can't believe that they still pull this out. All right, so we can use double angle formula for sine. So remember sine A plus B is sine A. This is in the formula sheet, right? Cos B plus cos A sine B. So here I'm going to use sine 2x plus x, yeah? So it's 2x being A, so this is sine 2x cos x plus cos 2x sine x. Not that hard, guys. And then we got to change everything into sine. So here we have sine 2x, so that can be 2 using the double angle formula, 2 sine x cos x, and then another cos x, plus the cos 2x, I'm going to change it to another double angle formula, 1 minus 2 sine squared x, and then times sine x as well. Okay, moving to left a bit because I'm out of space there. So as you can see, these two guys multiply. Oops, I forgot a cos x here. There you go. Maybe I should make that a little more clear. There. So these two guys multiply to be cos squared, and by the identity, cos squared is 1 minus sine squared, right? The normal identity. And then if we multiply this inside, we get sine x, yeah, just multiply that in to every term. There you go. And then for this one, again, multiplying all out, I get sine 2 sine x, and then 2 sine multiplying minus sine squared, I get minus 2 sine to the power of 3. There. Simplifying every term, writing everything back again. So collecting the like terms, how many? Yeah, I get a minus. So I get a 3 sine x minus 4 sine cubed x. Okay, so that seems fine. That's familiar. I think I'm familiar with that. So I'm going to say that this is my answer. Okay, so that's part A. It's part B. So part B, hence or otherwise, solve for that. So, well, yeah, on the left we have sine 3 theta. So we're going to keep 2 there. 2 and then sine 3 theta, we just prove it to be that, right? So at least if anything goes south, we get marks for this. Okay, and then equals 5. Again, sine 2 theta. Well, yeah, we can change that to a double angle, but the double angle formula, but then there's going to be cos for you there. That's going to be a cos. Right, hang on, let me think through about this. Okay. So, okay, we can try to do that. So it's a multiply 2 sine theta cos theta. Why do I get an x here? It should be a theta, sorry. Okay, there you go. All right, so yeah, we should factorize that. Okay, so I'm gonna multiply out the left side, so I get 6 sine theta minus 8 sine cubed. Yeah, bringing this 10 sine theta cos theta to the left, I get 10 sine theta cos theta equals 0. Okay, so occurs to me like I can factorize one sine out at least. Yeah, so that will hold some answers because you can put sine theta equals 0 and get some answers. So I get 6 there minus 8 sine squared minus cos minus 10 cos theta. Now I know what to do next. Because, yeah, this guy can be changed to a cos, right? So now already we have sine theta equals 0 as part of our answer. Okay, and then or 6 minus 8. So here, guys, I'm going to change sine squared to 1 minus cos squared again, being careful with the sign, right? And then minus 10 cos theta equals 0. Okay, let's deal with the sine theta being 0 first. So, well, we should happen to know. I mean, you should at least know that sine theta being 0, that would mean theta is 0 or 360 or 180. So we get quite some angles here. So theta is 0, but 0 is not allowed in the domain. So we don't take that. We take 180. Yeah, that's allowed. And another one, 360. You can check by the calculator, right? So we get some answers for that. Now, this, guys, we got to solve, right? It's a quadratic, a trig equation. So 6 minus 8, expanding all in, we get that. Minus 10 cos theta. I'm just going to double check everything, yeah? Okay, I'm always careful when I expand things, right? And maybe you should be too. So, yeah, minus 2 equals 0. Okay, yeah. So again, I would like to factorize by myself. So I'm doing simplifying it by dividing through by 2. So I get 4 cos squared theta minus 5 cos theta minus 1 is 0. Well, I think I can do a 4 cos theta here with another cos theta here. And then I do a 1 and a 1. So that is, well, I can't do that, can I? That doesn't work. Oh, no. But let me check my working here in case I made a mistake, right? Okay, in case I make a mistake. So, okay, this is from the previous question. So 6. Okay, this is 10. So I move to the left. Okay, I get that. And this is 6 and that. Okay, I took a sign out. I get 6 minus and minus. Okay, and then this is 1 minus cos squared. I get a minus and then a plus. That should be fine. Yeah, okay, right. So this is not possible by factorizing. And I do not have a calculator that can solve quadratics. So I'm just gonna use, so this is just quadratic formula here. Minus b plus or minus square root b squared minus 4ac, all divided by 2a. So minus b plus or minus square root b squared minus 4ac. Yeah, all divided by 2a. That's just the formula. So, okay. So that is just, so I'm going to put in brackets, sorry. Yeah, fraction, not brackets. So minus 5 is 5, basically. I'm just going to do a plus first, and then I will do a minus later. So that's just 25 plus 16, which is 41. All right. Yeah, 25 plus 16 is 41. And on the bottom here, I have 8. Okay, that's one of them. Okay, I'm just going to write 1.42539 dot dot dot, or equals, the other one, change that to a minus. We got minus 0.17539 dot dot dot. As you can see, because cos cannot exceed 1, so that is going to be no solution, right? But we're going to take this. So we're going to do a cast diagram for that cos theta solution. Okay. It is a negative, right? So we're going to do, so that is the negative there. But what I'm going to do here, I'm going to change that to a positive by just swapping these two guys. Change that to a, because I want the exact solution. So that's a minus 5 there. Yeah, so it would become positive instead. And what I'm going to do is I'm going to arc cos that whole thing to get my basic angle. There you go. So that is my basic angle in degrees. So arc cos of 0.17539 dot 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 is equal to 79.8986 dot dot dot. Okay, so this is my basic angle. So again, cos being negative, we want the second quadrant and the third quadrant, and basic angle being here. I'm not going to write the angle down. So we want, yeah, from 0 to 360. So I go like that and like that, right? Okay. So one being, 180 minus the basic angle equals, so I'm going to do 180 minus that. Okay. All right. Keep it to an answer first. Hang on. Equals. And then 180 minus that. Yeah. So I get 100 point. So how many decimal place? 100.1 degrees. And theta is 180 plus BA. So let's see if I can do that. 180 plus answer. No. Okay. This is not good. Yeah, that's fine. 180 plus 79.8986. That should be enough. So I get 259.9. That's another one. Okay. So as a result, my answer for this one is theta equals, we have four solutions. Ordering from smallest to largest would be 100.1 and 180 and 259.9 and 360. Okay, so that's all the solution, guys. Let's move on first, because time is ticking too. So number 6. The functions f and g are defined by these. Okay, we find g of f of 2. So we find f2 first, maybe. So f2, we just substitute 2 in there. So that's going to be 6 minus 21 over 2 times 2 plus 3. So 2 times 2 plus 3 is just 7. 21 divided by 7 is 3. So 6 minus 3 is 3. All right. And then we do g of 3 there. Yeah, g of 3 would just be 3 squared plus 5, which is 14. All right. Okay. So 14 is the answer then. Okay, so that's done for A. For B, find the F inverse. Okay. All right, so F inverse seems like we need to do some decorating there. So I'm just going to make yx and make xy. So x equals, because fx is basically y, now I'm changing to x to find the inverse. So that's 2y plus 3. Now we want to isolate y. Yeah. Well, the way I would do this is sort of like, okay, if I move, I'm not going to do anything to the fraction yet because that would mess up the y. Y being in one term here is already nice. So I'm just going to move the fraction there to the left first. And then I get 6 and minus x together like this. Yeah, this is just my technique. And then what I can do here is that I can look at these as big groups and I can swap them. So I have 21 over 6 minus x there equals 2y plus 3. Yeah? And then do you see that? Hang on. Yeah. Do you see that you can sort of subtract both sides by 3 to make y becoming more alone, but now you have a 2y. And the rest is just dividing all by 2, right? So that would be 21 over 2 and then 6 minus x here minus 3 over 2. So that's basically our y. Yeah, so just dividing through by 2, we get that. Now, if you want to simplify this whole thing, then you can, right? Because you just need to multiply the 6 minus x here on top and bottom for the 3 over 2 there. So we can merge them. So 21. I'm just going to do y here on the left. So 21 and then minus 3 on the top, we multiply by that. And at the bottom, they can have the common denominator like that. Okay? And just finishing up. So expanding 3 and 6, you get minus 18. Subtracting 21, you get 3. This would become plus 3x. Yeah. So it would be nicer to write 3x plus a 3. All right. Just checking, actually. Okay. And this is over 2 and then 6 minus x. So that's fine. Or we can expand it in. So let's do a minus x here and a plus, not minus x, minus 2x and plus 12. Right. Yeah. So that would be my F inverse. Okay, there you go. Yeah, let's check a bit actually. So I move that to that, and then swap these, and then minus 3 here, and then divide across by 2 to multiply that, to multiply at the bottom here, and then, merge the fractions together, simplify the fractions. That is minus 18, so I get 3 here, plus 3x there. Multiplying all out, I get that. That should be fine. Solve the equation g of gx equals 126. All right. So g of gx is basically, you put the whole gx inside the x of the g. So because x squared is now going to be the whole gx function, so it's that squared again. Yeah, you put the whole function in that term, and then plus 5. So it seems like I need to expand, maybe not. I'm not going to do that yet because I need to equate this to 126, right? So let's see. So if I slowly solve that without having to expand, I'm going to get that equals 121. Okay. So here, if you take a look at this, you're going to have to square root both sides, and you might get two roots here. So if you square root both sides, you get plus or minus 11. Yeah. So from that, then that means x squared would be 5 subtracting a plus 11, you get a 6. But 5 subtracting a minus 11, you get a minus 16. Well, x squared is minus 16. That is not quite possible. So we're going to just take x squared being 6. So that means x just is plus minus root 6. Yeah, so that would be the answer quickly there, I think. Let me check everything again. Yeah. Okay. I think that's fine, guys. I'm just going to go ahead and skip to the next question. So my answer is plus or minus root 6 for that one. Number 7 now. Okay, 7. Curve C has equation y equals fx. And then we have fx as that function. That is x cubed, right? Yeah. Show that f dash x is that. Okay, we differentiate, right? So f dash x, just differentiate the whole thing. Well, it seems like there are two main functions multiplied together, so we're going to use a product rule. So it's like udv and vdu. So u being the front one, maybe the first one. dv, so I'm differentiating that. Okay, I'm just going to write d by dx differentiating. So I'm differentiating 4x plus 7, but I'm just changing it to a minus 1 here. This is not differentiated yet. I'm just going to differentiate in the next step. Okay. u dv plus v. So v is just that. Yeah. I'm just changing it to an index form times du. So du is basically differentiate x to the 3. So we get 3x to the 2, right? Okay. Now differentiating that, right? Okay. So it's just minus 1 here. And then 4x plus 7 raised to the power subtracted by 1. Okay, but because inside these brackets we have to differentiate again, this is a chain rule, so we differentiate again inside the whole brackets, the so-called the inner function, we get a 4, right? Okay, it's just that whole brackets there. And seems like you can maybe, okay, I'm just gonna put this into a fraction now because it's the power of minus 1. Wait, hang on. Aha. This is wrong, guys. I thought this is somehow okay. This is weird. Sorry. This is to the power of 1 over 2. I don't know why I put a minus 1 there, and good that I see it. Okay, so yeah, this is power half. Sorry. Okay, so I need to change this. So it's not minus 1 anymore. This is a half. Okay, and then 4x plus 7 to the power of minus 1 half instead, and then a 4 still there. And this is still, yeah, the same thing. All right. Okay. So minus 1 over 2 cancels with 4, get 2. What can we do? Okay, it seems like it wants you to bring that down. Okay, right. So if I rewrite this in fraction form, I get 4x to the 3 divided by, so this is a power of minus. You can bring it down, so it would become 4x plus 7 to the 1 half. But then I can say it is also a square root, right? If you don't follow that, you can just wind back and take a listen again. Yeah, so this is just the first term. Plus, well, I can write that as a square root 2. So I bring 3x squared in front to make it a little nicer. And that is not done yet, but because I see that the question wants you to bring the square root term down. Okay, now I already have it down. And then I'm going to merge the fraction, right? Yeah. So I'm just multiplying by square root of 4x plus 7, top and bottom on the right term here. So the left term is still the same, plus. And that now becomes just a 4x plus 7, right? Because I multiply top and bottom, merge the fraction. So here multiplying all out, I get, yeah, I don't need to do that, right? I can, what can I do? Yeah, I'm gonna take, interesting. Right, I think I should expand first, no? Hang on. Doesn't seem like I have the same kind of thing there. Um, yeah, that looks different. So there is only one, yeah, there is only one x cubed term and x squared term where I have, oh yeah, sorry. Yeah, it must be, yeah, 12x cubed and then plus 21x squared. Sorry, yeah. Okay. So yeah, simplify that. I get 14x cubed and plus 21x squared. Okay, and then you can see that 7 is a factor, x squared is also a factor. And then we have 2x here plus 3. Nice. We just got it. Okay, so this is as required, where k is a constant to be found, which is 7 here. Question B. The point P shown in figure 3 is the minimum. P is here minimum as a turning point on C. Is the minimum turning point on C. Yeah. Find the coordinates of P. Well, we can just equate this derivative function to 0 because that's where the turning point is, right? So derivative dy by dx being 0. So if we equate this to 0, okay, imagine, yeah, you will be able to multiply square root this on both sides and cancel that out. So I'm going to get, so I'm writing that first, and then I'm going to get 7x squared and all that equals 0. Because we can ignore the denominator part, doesn't do anything. And here we already see one answer here from the x squared, x being 0, or 2x plus 3 being 0. So x is minus 3 over 2. So x0 is already the kind of like the inflection there at the origin, but we want p instead, right? So we want to find the coordinates of p. That means we need to find the y value as well of p here. So y value, we put x to the original function, which is f of minus 3 over 2 there. So it's going to be minus 3 over 2. That is a cubed, and then times a square root of 4 minus 3 over 2 plus a 7 there. Okay. I'm going to need a calculator for that, but do we need to find exact? We don't, but can we? Yeah, we can. Because 4 cut 2, you get 2. 2 times minus 3, you get minus 6. Minus 6 plus 7, you get 1. So square root 1 vanishes. And this will be just 27 minus 27 over 8. So that is the y. That means the coordinates of P would be x being negative, y being negative there. That should work. That's quadrant 3. So I like that. So part C, hence find the range of the function g defined by that. Okay, range of function g. Gx is just minus 4 times, so it's like a flipped function and stretched by 4 times. But you got to be careful. X is greater than a minus 7 over 4. All right. So if you stretch the thing, let me just get this function here. No, I shouldn't. Okay, that's fine. If you stretch the thing, let me draw it briefly and multiply by minus. So it's going to flip, right? It's going to flip, but then it's going to, so that's the right part being flipped. And then it's going to do that. Well, this is already stretched by 4 times. So whatever the p we got just now, we need to stretch the y value by 4, but x being the same. So 4 multiply the y value here we got earlier. So we get minus 27 over 2 multiplied by 4 already. And this part is just a flip, right? So what do we want here? We want to solve for gx equals that, where x greater than minus 7 over 4. Minus 7 over 4 seems familiar. Okay. So I think minus 7 over 4 is here, no? Yeah, seems to be further away to the left from the turning point there. And yeah, we want to find the range of this function, the flipped function here. So the range just, start from this point and go down forever. All right. So the range of g would be y less than or equal minus 27 over 2. Yeah, that would be my answer there, guys. Yeah. Okay. So part D, point Q with coordinates that lies on C. C is the same curve. Yeah, not the new one. Find the coordinates of the point to which Q is mapped when C is transformed to the curve with that equation. Okay. Okay. So transform with that equation. So what does it do to the X? Okay, from Fx, and then you have, so this is moving X by 3, multiplying the Y by 40, and moving up by 8. Okay? So moving X by 3 over 2, sorry. So you're going to have that plus 3 over 2 for the X. So this is X of Q equals, and just that. But, so this is 2, right? So that's 4 over 2, which is 2. And the Y of coordinate of Q would be 3 over 8 multiplied by 40 and minus 8. Yeah, just 40 outside, you multiply the Y by 40, and minus 8 is just shifting down. So that would be 8 cut 40 gets 5. 5 times 3 is 15. 15 minus 8 is 7. Okay, so my new point, Q prime, would be 2, 7. That's the answer. Getting away with it, guys. We are running out of time. We are number 8 now. Oh, okay. I should have just add more page there first. Hang on. Okay, that's fine. Now I'm going to have this kind of line instead. This kind of page. Okay, number 8. Oh, this is a long one. And then we have number 9. Okay, we got to be quick now. Number 8, this whole thing, it seems like a harmonic function. No, it's not. It's just an exponential. So state the initial heart rate of the horse. So A, the initial heart rate, if we put everything to 0, yeah, if we put T to 0, that would go to 1 and 1. So initial heart rate when T is 0 is, we have H being 32 plus 40 minus 20. So that would be 52, right? Yeah. Okay, 52. Okay, here we go. And then in the long term, the heart rate of the horse approaches L BMP, beats per minute. State the value of L in the long term. So in the long term, it means that T would approach infinity or some large value. Now, guys, when you have e to the minus x and x approaches infinity, that means e to the minus x will approach 0. because the graph looks like that. It's the exponential and flipped in the y-axis, right? So it's going to approach a zero there, the y value. So that means all the e to the minus blah blah t will approach zero, all of them. That means h will approach 32. Okay, so this is the answer. So h equals 32. All right. Okay. So C, the heart rate of the horse reaches its maximum value after t minutes. Find the value of t, give me your answer to 3 decimal places, 5 marks. So we need to find the derivative first. Okay, so derivative dh by dt, well, we got to differentiate all those. Yeah. So differentiate 32 goes to 0. So differentiating this, I'm just going to bring minus 0.2 down to multiply 40. I get minus 8, right? E to the minus 0.0 t. Okay, that's just kind of like a chain rule there. And then again, similarly, bringing minus 0.9 multiplying minus 20, I get a plus now, a plus 18 e to the minus 0.9 t. Yeah, clear? Okay. And because we want to find the maximum value, it looks like around there, we need to equate that to 0, right? The maximum value. So equate this to 0. What do we get? Well, it seems like we can do this. So I'm just going to bring this to the other side. So I get 18 e to the minus 0.9 t equals 8 e to the minus 0.2 t because I have moved it to the right side. And if we sort of like move the numbers with the numbers together and e with the e like this, right? You can see that we can use laws of indices again. It always helps. So when we have that divided by that, it's going to be m a to the m minus n. So 18 over 8 is just 9 over 4 equals that minus minus that. So is a plus. Okay, which is e to the, what's that, 0.7 t. Yeah, just adding up the terms. So e to the 0.7 t is 9 over 4. That means we can do the log trick again. So bringing e to be the base of the log on the other side, we get a ln instead. Yeah, so a ln 9 over 4. Okay, so we want the t here, giving you answer to 3 decimal places. So yeah, I'm just getting a big T here, which is the answer to this. 0.1 over 0.7 ln 9 over 4. And that gives me calculator. So 1 over 0.7, oops, and then multiply a ln of 9 over 4. There you go. And that gives me 1.15847 dot dot dot. And that's going to be rounded to 3 decimal places to be that. Okay, that's C done. D, the heart rate of horse is 37 beats per minute after m minutes. Show that m is a solution of that, and then we're going to do iterative formula. So I'm just doing the heart rate. Wait, hang on. The heart rate of the horse reaches maximum, let's say. Okay, I'm just checking if C is, yeah, we differentiate, equate it to 0, and find T. Okay. Now, for D, we just equate 37 to the original equation because the heart rate is H, basically. Yeah. So, all that. Okay. So, we're just going to solve this, yeah? Yeah, but no, not exactly. We're just going to make this equation, and it's 2 marks. Okay, so moving that, we get 5 equals. Well, I can, let's see what I can do here. So I'm going to have to keep the e to the power of minus 0.9, right? Somehow. And then I have, let's say I bring 20 out first. Okay. So, All right, so bring 20. I have 2e to the minus 0.2t minus e to the minus 0.9t, right? Just bringing 20 out. And bringing 20 on the other side, I get 1 over 4 here. So what should I do with this, guys? Let me think that a bit. Okay, so this is what I'm going to do. I'm going to, yeah, okay. So after bringing 20 down to divide 5, I get a quarter here. And then I'm going to move, yeah, after, you can see that after moving 20 to the other side, I'm going to have this being added with that. But then I'm going to move also the 2e to the minus 0.2t. Sorry, I should move the other one. Yeah, I'm going to move this one instead. So it's going to be a plus e to the minus 0.9t. The reason why I did this because I see this being together, kind of like a 4 and a 1 there. So, and I'll show you why. Okay, so we just have left on the right side as being that. Now, the reason I do this because I can get rid of this exponential by just taking ln later on. But because I need to keep e to the minus 0.9t, right? And this is basically, if you do the fraction there, you're going to have 1 plus 4e to the minus 0.9t divided by 4. And if you also bringing 2 to the other side, i.e. bringing 2 down here, right? You're going to get 2 multiplied 4, we get 8 here instead. And the other side without 2 now. Just like that, right? See, I'm getting closer to that. Now, before I'm going to take ln, right? Because this is a negative power, I can make it a positive power. Just basically what I would have done here is sort of like power it by minus 1 on both sides, or flip everything upside down, right? So flip everything upside down, I'm going to get a positive here, and here would be 8 over 1 plus 4e to the minus 0.9t. And here I'm going to take ln now. Okay, so take ln on the left. Yeah, take ln. So take ln on both sides. It's like moving e as the base. So log base e is ln. Yeah, same thing. So I'm getting closer to it now. And then I'm going to change. So basically 0.2 is equal to 1 over 5. Yeah. All right. So 1 over 5, imagine here, moving 5 up to multiply that. And I'm switching the side here. So I get what I want, basically. And that is just as required, guys. Done. Okay. And now use the iterative formula in E. Find 4 decimal places. Okay. So we're gonna use T1 equals 10 first and find T2. All right. So T2 I'm gonna have to write, maybe. They require you to do that. And then later on, we can just do iterative. So I'm just multiplying by 10 there in the power. Yeah. So I'm just going to do 10 equals, that would be my stored answer as T1, and then do the 5 ln fraction 8 underneath. We have 1 plus 4 times e, where's e? E to the power of minus 0.9 times answer, because that's where T1, Tn is, yeah? Everything looks good. And then I'm going to close the bracket here. That is just the second T, 10.3, 4 decimal places, 3947, yeah? That's I and I. So I'm just going to keep hitting the equal sign here. And as you can see, the value of m is just converged there. All right. So after 4 decimal places, m is going to be equal to 10.3955. So that's just a little bit away from 47. All right. Okay. So that's done. Let's get away with that and do question 9, the last one. All right. So figure 5 shows a sketch of the part of the curve C with equation that find f dash x again. They would like you to do a lot of calculus, right? Maybe. Okay, differentiate that. It occurs that I should do a quotient rule. Should I? Yeah, probably. Okay, so let's do a quotient rule. So bottom, differentiate top. So differentiate top, I get bringing 2 down, I get 12x there for the first term, and then plus 4 because x goes away, and minus top. Yeah, that's the top bit. Then you differentiate the bottom, we get 2, and all divided by the bottom squared. Okay? In the simplest form, so basically we should expand these all out. So that's going to be 24x squared for this one. I have 12x here and I have an 8x here. I get all of them 20x, yeah? And then I have a 4 here, okay? This one I gotta be careful. I'm gonna need to expand everything in first. So I get a 12x squared. So that's a minus 12x squared considering the minus sign. And that's an 8x. So that's a minus 8x. And that's a minus 4 minus. So that becomes a plus. All divided by that. I'm not gonna expand that, guys. See if I need to, but I'm gonna keep it as that for the time being. Simplifying the top part, I get 12x squared. This is basically what? 20 and a minus 8, I get 12x again. Okay. And a plus 8. All right. Okay. So, yeah, you can bring 4 out. And if you bring 4 out, you get 3x squared plus 3x plus 2. Can you factorize that? No, I don't think so. No, I don't think so. So I'm gonna keep it as, well, that tells me maybe we should expand because the top part is expanded. So I'm gonna do like 4x squared plus 4x plus 1, expand it all out. So that's my final answer there. Yeah, simplest form. Yeah, that's fine. So that's A. B, the line L is the normal to the curve at 0.26. Show that the equation for L is that. So normal, guys, know that it is normal. So we're just gonna find the tangent, the gradient of the tangent first. We equate, we use dy by dx here. So we do f dash 2 because we are substituting 2 into the derivative function. Okay. Yeah, maybe I shouldn't have done that. Yeah, it's just fine. It's fine. Okay, just substituting that. Okay, I can just use that function instead because it's shorter to write. Okay, so 4, so this is 4 times 3 is 12. 12 plus 6 is 18. 18 plus 2 is 20. 20 times 4 up there. Yeah. Okay. And down here we have 5 to the 2, which is 5 times 5. Yeah. So is 16 over 5, basically. All right. So that is the gradient of the tangent. So the gradient of the normal should be minus 5 over 16. Just flip the fraction, put the minus. And then do y minus y1 being the point P because it cuts there. Okay, equals m x minus x1 being 2. Okay, multiplying out by 16, I get 16y minus 16 plus, 16 times 6 is 96. And multiply minus 5 all out, I get minus 5x here, then plus 10. Moving everything to the same side, I have 16y in front plus 5x. And then that would be 96 moved to the right, I get 106. So that sort of like confirms that I'm fine with all this. The first and the second question. No coincidence. And C, Write fx in the form of that. Aha. Okay, so when there are the quotient parts here, it means you need to do a long division for that first. Yeah, okay, we're gonna do a long division. All right, guys, that's fine. A long division. So we're gonna get a quotient part, ax plus b there. So the first term divided into the first term, we get 3x only, and then 6x squared plus 3x there. Subtracting the first two line, we get 0 there for the first term, and this is x, bringing next term down, minus 2. And okay, so this is 2x divided into x, we get a half, right? Yeah. So multiplying back, we get x here and a half here. That's a bit odd. And this is minus 2 minus a half, so we get minus 5 over 2. This is a bit odd, but okay. Because a, b, d are constants. Doesn't say that it's an integer, so I think we're fine here. Let's double check. 6x squared, 3x minus them. We get a 1, and then the minus 2 brought down. Yeah, okay. And then first term divided into the first term, we get a half. Yeah, so a half x, and then apply a half there. Minus 2 minus a half is minus 5 over 2. Yeah, I think we're fine here. Okay, gotta add another page again. Right, but it's fine. Okay, so right, so fx would be equal to, now we have so this is the remainder. The quotient ax plus b is 3x plus 1 over 2. And then d would be minus 5 over 2. And then the divider is again 2x plus 1. That looks a bit weird, but I probably need to check this one again. All right, but yeah, I'm gonna remember that. The region R shown in the shaded in figure 5 is bounded by curve C and L and the x-axis. All right, got it. Use algebraic integration to find the exact area of R, giving your answer into the form of that. Okay, so we need to find the x-intercept here of the line L first, and the x-intercept of the curve, right? So let's do the x-intercept of the curve first. So we put fx equals 0 and find the x of that. So as you can see, we can multiply all out both sides by the denominator. So yeah, we get 6x squared plus 4x minus 2 equals 0. Yeah, multiplying out by denominator. And then we're going to solve for this quadratic, basically. Okay, can we factorize that? I think we can. So 3x and then 2x here for the front term. And then I'm going to do plus 2 here and minus 1 here. There you go. Bam. Already. All right. So here we're going to have x being minus 1 and 1 over 3. Because we don't want the negative part, we cut that out. So that is our solution there to that point. Yeah, to that point on the left here. And then for the line, x-intercept of the line. So the line, we got the equation from B already. So we put y equals 0 there for the line to solve for x and find the intercept. So that goes to 0. That means x equals 106 over 5, right? For that. And I'm going to keep it as that because we want exact. Now we're going to go ahead and integrate, but you got to split that into two parts. The first part being this up to point P, and I'm going to just draw the line down here. So this is part 1. And this is part 2 being, again, the same line here at P, but just a triangle. Yeah? So it's like drawing this line down. So this point here, x being what? 1 over 3, right? And this is the x coordinate of point P, which is 2, just down here. And this is 2, and this coordinate is 106 over 5. That's quite further away. Okay. Interesting. Yeah, that should be fine. It's just the diagram is not to scale, basically. Okay, so this one is basically 1/2 times base, which is 106 minus 2 there. Just the length of the base here. and the height being the y coordinate of the point P being 6. Okay, whatever that is. And here we need to do integration, right, for this part. So for this part, integration, okay. So the bounds will be a third up to 2, and then we integrate the whole thing. This is tough. All right. Oh, because we got the nice term here already, so we're gonna take it, assuming that we did it right at the earlier part. So here I'm gonna simplify a bit. So I'm gonna maybe so I'm gonna write it like this, guys, and then times 1 over 2x plus 1 like that, integrating the whole thing. Yeah. So this is gonna be okay. So I'm just gonna integrate first. So the first one, x to the 2 over 2 like that. Second one being x over 2, just adding an x to a constant. And this one got to be careful. This is a ln. So you integrate 1 over ax plus b, you get a ln of absolute 2x plus 1. But then don't forget, you have a reverse chain rule because it's not just 1 over x now. It is 2x plus 1. So you got to also divide everything here by 2. So doing that would give me here a 4 instead because it was just multiply the denominator there. And then I have a bounds of 1/3 to 2. Okay, so this one will add this part. So here what? Okay, 106 minus 2, sorry, minus 10. If I do the fraction there, that would give me a half times 96 over 5 times 6, right? Yeah, 2 cut 6, I get 3. So that would be 288. Yeah, just by my calculation over 5. Okay. All right, so this is an interesting substitution here. So, okay, let me see. 2 substituting in every term. I'm going to do mental math there. I'm getting 6 on the first term. Yeah. I'm getting 1 on the second term. And this is 5 over 4 ln 5. And then substituting the whole thing by a third. That's horrible. Is 3 over 18 on the first term. Yeah. Plus 1 over 6 on the second term and minus, oh, this is more horrible than that. Okay, this is a ln of 2 over 3 plus 1. That's so horrible. Okay. Okay. So I have a 7 here and a minus. Okay, let me use a calculator to help me with that. So a 7 plus, no, minus 3 over 8, right? And then, no, 18, sorry. And then plus, no, minus 1 over 6, right? Because I'm expanding the minus sign there too. Ooh, this is horrible. It gives me 6.666, and that is 20 over 3, I think. Is it? Yeah, okay. So that's 20 over 3. And then the ln part is a bit tricky. Uh-oh, I forgot to write ln here. So wait, so this is 2/3 plus 1. It's 5 over 3, yeah? 5 over 3, remember that? So I'm just going to change to ln 5 over 3, right? Okay, so what is this? This is minus 5 over 4 ln 5 and minus minus, so that is a plus, right? 5 over 4 ln 5 over 3. Horrible. Okay, but that's fine because we got that. And then this is 5 over 4 factorizing out. I'm getting that as ln 5 over 3 minus ln 5. Yeah. Just swapping the term a bit. So that is 5 over 4 here. So here you can do log property. So ln 5 is basically ln 5 minus ln 3. And then you have a minus ln 5 there. So it's not that horrible if you keep going, right? So here we have 20 over 3 minus bringing out. I have minus 5 over 4 here and ln 3. P and Q are rational constants. So I think I'm going to stop there. I'm pretty okay with that and everything. Okay, I think I'm kind of done here, so I don't have much time to double check. I'm gonna double check this one first. So we can start from part C, right? Because that's where I'm not confident about. So it's like we are dividing by, yeah, that first. So, okay, so yeah, right. Okay. Yeah, when I do it again, I still get the same answer. So yeah, so this is still okay. And then that's the remainder, right? Yeah. So I think I'm okay with this. And then D, use algebraic integration. Yeah. So we're gonna integrate the curve part. The curve part we need. So what did we do here? We did that equals 0 because we want to find the x-intercept, and we got a third of that. Just checking the quadratic expansion again. I got still the same thing. So that is it. A third there. And I'm substituting y0 to get the x-intercept of the line. I get that right. Okay. And this is -2 because we want to find the base of the triangle. We get 96 here, multiplying 6 as the height, which is point P. So yeah, that's fine. 96 times 3 is 288. Yeah, that's still okay. And then integrating this from the bounds 1/3 to 2. Yeah, that seems fine. And then we are integrating the like the this term fx we just found earlier. See if I copy everything right. Yeah, I'm bringing that down simplified here. And then I integrate that. Okay, so this is a reverse chain rule. That becomes a ln. And then I'm bringing 2 down. I get that as a 4. Substituting is a tricky part. So 2 cut 2, I get 6 here. 2 multiply that, I get 1. 2 in here, I get ln 5. Yeah, that's the first bit, the first bound. A third multiplied there, I get 3 over 9 times 2. Yeah, 3 over 18 here. A third multiplied x over in x over 2, I get 1 over 6. A third in there, I get a 2 over 3, but plus 1, I get 5 over 3. Okay, and then that. Bringing everything in, I get a 7 minus that. I'm going to trust my calculator, work on that, and then everything should be fine. All right. So question 8, fine. Let's go from the first one, right, guys? We still have 2 minutes. So which one am I not sure about? This one was fine, I hope. Yeah. And then substituting 10 as being sec minus 1, sec squared minus 1. And then that expanding that all out, I get that. Factorizing, I get that. But the cos of 3 over 2 doesn't have any solution, so I'm just paying attention to that only. Answer in degrees, 1 decimal place. So this should be fine. So this is the 2 answer there. Number 2, I got 2 minutes to double check. Okay. Differentiate, this should be fine. I don't think I'm concerned with this. Yeah, but they're both fractions though. Okay, yeah, putting that to 0. So y is -5 over 4, and substituting back into the original form to get x. That should be fine. Yeah, right. Yeah, I think that's fine. Oops. Oh, this is x. I thought I swapped the coordinates. All right. So number 3. Okay, number 3, I think is a bit tricky if you're not careful, because I did make a mistake along the way. Yeah, so I think I'm fine because I already checked this twice. So number 4, so yeah. Okay, so pulling that 10 to the 2 as 100 and 100. So B required you to answer in 2 decimal places for the B, and A can be exact. That's fine. Hence find the rate of growth. Okay, after 5 hours. So that is the rate of growth. But you need to differentiate that. You get ln of ln of that. Yeah, I try to make everything exact here. So I don't want to miss any precise answer there. Okay, I think I'm gonna just call it, right? My time is up, guys. Time's up. All right, we're gonna mark the paper. I'm gonna hit the timer here. All right, yeah, so that's it. Let's see how well I did it. Okay. Okay, so this is the mark scheme. All right, I'm just gonna go through and check from the first question. Yeah. Okay, so I nailed that part. Okay, and then answer to answer there, here should be fine. The second one, dx by dy by dx, sorry, is that? Yeah, I think that one is fine, minus 73.8, and then that. Okay, so go away. Number three, yeah, I plot the graph a bit and then have that line. So it's 8 and minus 8 there. And then I have this. Yeah, that's a bit further than the turning point, but anyway. Yeah, whatever this is, but yeah, okay. So attempt to solve. All right, I got that part right. And then 15 over 4 there, I got 2 marks. And then achieve both critical values, I did. And then correct, yeah, I think this is fine. Should be that. Although they don't quite show, but this is like an error that they have all the time. They don't have the sign there. That's the problem with the mark schemes. Um, okay, so this is 100. It's 100. Yeah, that's the right equation, and all that, I get that. So that's fine. Phew. Now after that, I didn't quite double check, right? So this is fine. Okay, so the final answer here already. That was taking my breath away, but I got all of them. So these should be right with no doubt. Number 6. 14. The first one. Where is, yeah, hang on. Wait. Correct attempt inverse. Ah, no. Oh, okay. I forgot to state the domain. And this is, where I also teach my students not to forget the domain. And here I did forget myself. All right. Bad, right? This is bad. All right. Yeah. Every time you find the inverse function, you need to state the domain. Yeah. Okay. Yeah, I lost 1 mark there. This is all totally my fault. All right. All right. Yeah. Yeah. Learn from your mistakes. Cool. But did I get the function right though? Yeah, that should be fine. That is right. But I lost 1 mark because I didn't state the domain. And that I got right for C. Okay. So yeah, the domain, yeah, if you go back, the domain is just, yeah, just that. Um, yeah, this part, f dash x, I got it. Yeah, so that should be fine. That is the coordinates of P should be that. Okay, so that's 2 and 7, that's right. And what is this? C. Oh yeah, okay. Wait, what? Wait, oh no. How can I get a minus here? It is above the x-axis. Okay, this is stupid, right? That was a silly mistake. Base. Okay, so I didn't attempt to solve for, well, I did attempt, but let's see the mark scheme. So see if I get any mark for this, right? But I'm surely not getting the A1 there, but let's have a look. So C, attempt that, which may be seen within inequality. Um, hmm. Allow it to be written without the correct form, such as that original function. So if x, that would be m1. Yeah, I got it. So I wait, what? No, no, hang on. No. Okay, I'm gonna be harsh here. I'm not gonna give myself marks for that because I didn't show any attempt to do that. So I'm gonna lose 2 marks here. Okay, fine. Yeah, at least I got that part right. Yeah, I think number 8 I should be all right because I double checked twice. So that's the first one. That's the second one. Wait, what? 1.13? That doesn't look familiar. Oh, 1 point. Yeah, sorry, it does. Okay. And that part I got fine because I can prove the required form. And this one, m is that. Yeah, nailed it. Derivative of f for number 10. Sorry, number 9, the last one here. Yeah, well, okay. Yeah, that's fine, I guess. Equivalent or equivalent, or E here means or equivalent. So this is equivalent to that because I got it from here. That's fine. Okay, so what is this? Yeah, I got this fine because I can prove the equation. C is a bit tricky because I didn't trust myself, but there you go. 3.5 and minus 5/2. Yeah, that's cool. Oh, last part, I didn't quite get. No, I get this part right, but what about that? Right, guys, lose another marks again, maybe another bunch of marks. This is fine. Yeah, and I got the M mark here and dm here, area under the curve, right? Okay, so I'm gonna zoom into that a bit. Yeah, I got everything accordingly here, substituting the right bound as well. That is maybe because I didn't use a calculator for that. Right. But if you do, you probably wouldn't get an exact form. I don't know. Yeah, hang on. Yeah, this is not a simplified of that, so I don't know what happens there. Maybe I did make a mistake. Maybe this might be wrong. Okay. I know, I mean like I put in the calculator wrong basically. So I lose an accuracy mark here. Just the one. Just one of them. Yeah. Okay. So just -1. So I lost in totality one, I think 4. 2 here is 3 now. 4. Yeah. I lost 4 marks. So that is 71 out of 75. Well, okay. I think this paper was quite tough because the one before this, like the May, June 2024, I finished at 1 hour and 20 minutes. And this I finished like 1 hour 25. So I was almost out of time. I had some time to double check, but that didn't make much of a difference. So P3 is tough anyway, right? Everybody knows that. And you got to be quite sharp when you go along the paper. So don't waste too much time in thinking too much or being too stubborn about some question you can't do. And I made some mistakes along the way again, right? So you got to be the most careful you can because for the easy questions, you cannot afford to lose marks. Because if you lose marks in the easy ones, what about the difficult ones? Right, guys? I hope that was helpful. Don't forget, guys, keep studying. I'll see you in the next video. Bye.